Hello everyone, welcome to Civil Engineering and stuff. And in today's video lecture, we are going to discuss about an important fundamental parameter of traffic engineering, and that is traffic capacity. So traffic capacity is the fundamental parameter that is used to assess the traffic. Apart from that, we have traffic volume, we have traffic density, and we have traffic speed. So all these four, that is your traffic volume, traffic density, your traffic speed, and traffic capacity are the fundamental parameters that are used to assess the macroscopic parameter of traffic engineering or traffic stream. So let us discuss about the traffic capacity. What is traffic capacity? So traffic capacity is defined as the ability of roadway to accommodate the traffic volume, or it can also be defined as the maximum number of vehicles in a lane or road that can pass a given point in a unit time. So what does this mean? This means that in a road section, this is our study road section. This is our study road section. In a unit time, this unit time can be 1 hour, can be 1 week, it can be 1 year, it can be 1 day, depending upon the extent of the traffic study. So in this unit time, how much amount of traffic volume? So we have discussed about traffic volume. Traffic volume is amount of vehicles crossing the road section in a unit time. So traffic capacity is the maximum amount of traffic volume that this road, which is our study section, the road can accommodate in unit time. Okay, so to simply understand, your traffic volume assesses the amount of traffic the number of traffic that is crossing the road section in the unit time, while your traffic capacity assesses the capacity of the road that can accommodate the traffic volume. Alright, so in traffic capacity, the point of reference is the road. In your traffic capacity, the point of reference is the road section that you are taking under purview, that you are taking under the study. So the maximum number of traffic volume, the maximum number of vehicles that this road can accommodate, the maximum number of vehicles or the traffic volume that this road can accommodate in the specific time of study is called as the traffic capacity. So again, let's look back at the definition. It is the ability of roadway to accommodate traffic volume. Ability of roadway. The point of reference is the road section. So the amount of vehicles in a unit time the road can accommodate. Alright, the maximum number of vehicles in a lane, if a specific lane is in our purview of the study section, or if it is a road, then that is our purview of study section. The maximum number of vehicles that the road can accommodate or can pass in a given unit of time. Okay, so the traffic volume is the traffic capacity is the maximum number of traffic volume, that can pass through road section. That is very important point. The point of reference is the road. We are looking at the capacity of road, that how much vehicles can pass in a unit time from this road section. Okay, so how much vehicles that can pass through this road section in a unit time is what we call as the traffic capacity. Okay, so there is a difference between traffic volume and traffic capacity. We have discussed about this in a previous video. You can refer to that. Okay, now the unit is same as traffic volume, that is vehicle per unit time. The unit of traffic capacity is same as traffic volume, that is vehicle per unit time. Why? Because it is also assessing the number of vehicles that can pass through the study section in the in the unit time. It can be 1 hour, it can be 1 day, it can be 1 week, it can be 1 year, represented as vehicles per hour. Alright. But the difference is here we are looking at the serviceability or the ability of road. Right? We are looking at the ability of road. How much traffic volume can pass through the roadway. Okay, so this is the traffic capacity. Unit is vehicles per unit time, represented as vehicles per hour. If you are looking at the specific lane, then the unit will be vehicle per hour per lane. Okay. Now your traffic capacity is divided into three categories depending upon the way in which you identify the capacity of the traffic. So the first type of traffic capacity is the basic capacity. The first type of traffic capacity is basic capacity, and it is defined as the maximum number of vehicles that can pass a given point on a lane or a roadway during 1 hour under most ideal roadway and traffic conditions. Again, let's read this definition. The definition says it is the maximum number of vehicles or the maximum traffic volume that can pass a given point or a lane or a roadway. That is our study section. The maximum number of traffic volume that can pass the study section during a unit time or during 1 hour under most ideal roadway and traffic condition. Most ideal roadway and traffic condition. What does this basic capacity mean is that again we have our study section. We have our study road section. Now, in this road section, if we assume that all the traffic is abiding to the rules and regulations of the movement in the road section, they are abiding to rules and regulations. That is, they are following the speed limit. They are following the guidelines that have been provided, as well as the drivers also have sufficient amount of patience not to overtake the vehicles, right? They have the sufficient amount of patience to not to overtake, and all are following a specific speed limit, right? So we have, let's say these are cars, and likewise we have bikes, right? Again, we have bikes that are moving in between the traffic stream, and again everyone is following the traffic rules. They have the sufficient amount of patience. The vehicles are in good condition. There is no problem in the vehicles. Environment is also in favor, right? The environment is also very pleasant, and the visibility is also sufficient. So in that scenario, when everything is in our favor, at that time, what is the maximum number of traffic volume? The maximum traffic volume that can pass this study section in the unit time. Let's say unit time here is 1 hour. So maximum traffic volume, or the maximum number of vehicles, that can pass the study section in the unit time under most ideal scenario. That is, everything is in our favor. When everything is in our favor, the vehicles are abiding the traffic law. They have the sufficient patience not to overtake the vehicles, and they are following the speed limit. The pavement conditions are good. The geometric design is good. The environment is neat and clean. Good visibility is there. Everything is at a pinpoint condition, at the ideal condition. At that time, whatever the traffic volume that we are going to get is termed as the basic capacity of the specific roadway. Again, I am repeating, the traffic capacity is the road as the point of reference, right? So when this happens, then that is called as the basic capacity. When this happens, this is called as the basic capacity. It is the ideal roadway traffic condition. All right. So needless to say, it's a theoretical way of representing, right? It's a theoretical understanding. In no time you will see that even if there is good visibility, the vehicles uh, will overtake, right? It's a common phenomena. It's a general phenomena that the vehicles will overtake each other, right? There is some kind of impatience among the drivers, right? So this is somewhat a theoretical concept. Alright, this is somewhat a theoretical concept. So the basic capacity is also called as the basic capacity is also called as the theoretical capacity. The basic capacity is also called as the basic capacity is also called as the theoretical is also called as the theoretical capacity. Alright. So your basic capacity also called as theoretical capacity, that is under the ideal roadway condition. I hope it is clear to you all. Alright. So let's move on to the next traffic capacity, that is the possible capacity. The next traffic capacity is the possible capacity. Okay. Let's read the definition. The possible capacity is maximum number of vehicles which can pass a given point on a lane or a highway during 1 hour under prevailing roadway condition. Under prevailing roadway and traffic condition. So here what is happening is the maximum traffic volume that can pass a lane or roadway in a unit time under prevailing traffic condition. Okay, under prevailing traffic condition. So this means what does this mean? That in a road section, in our study section, what is the actual behavior of traffic that we are observing? Okay, what is the actual behavior of the traffic that we are observing? So what in actual on the field, what observation that we have got, right? So by observation we will mean that of course there will be vehicles that will be overtaking the other vehicles. There will be vehicles that will be going higher than the design speed. There will be vehicles that will be going at a very slower speed than the design speed. So because of which, when the vehicle is going at a slower speed, so what will happen? The preceding vehicle has to follow the slower moving vehicle. Likewise, there will be vehicles that will be going at a very higher speed and disturbing the overall traffic stream or concentration of drivers that which it is overtaking. Right, as well as there will be other factors that may interact to give you the actual traffic condition. All right. So the traffic volume that we are going to get in a unit time. Let's say the unit time is 1 hour. The actual traffic condition that you are the actual traffic volume that you are going to get under the prevailing traffic condition is what we call as the possible capacity. It is the possible, or it is the traffic capacity under the prevailing, the actual, or it is in the actual traffic condition, right? Which we are getting. So it is the possible capacity. Okay. Then we have the practical capacity. Then we have what we call as the practical capacity. The practical capacity is the maximum number of vehicles which can pass a given point on a lane or highway during 1 hour without traffic density being so great so as to cause unreasonable delay, hazard, or restriction. So what does this practical capacity mean? Practical capacity means practical capacity will be that maximum traffic volume. Practical capacity will be that maximum number of traffic volume that will cause no congestion and that will cause no delay in the traffic. It is the maximum traffic volume that will cause no traffic congestion or no traffic delay. Let me explain to you in detail. Okay. So what does this mean? So as we discussed, there will be vehicles that will be overtaking right? There will be vehicles that will be overtaking the vehicles that are moving ahead. There will be vehicles that will be moving at a very slower speed. So the vehicles that are following the vehicles that are moving at slower speed, they have to follow the slower moving vehicles, right? And as well as there will be other factors. However, in the prevailing traffic condition, in the prevailing or when this actual traffic condition is happening, there is there is no congestion. There is no congestion. Congestion means there is no traffic jam scenario happening. There is no waiting time for the vehicle. There is no traffic jam, so vehicles do not have to wait to cross this road section. As well as there is safe passage. Safe passage. There is no risk to life. Like let's say if vehicles are overtaking, right? But the overtaking is in a such a way that there is in an acceptable scenario or in an acceptable pattern, right? All the vehicles are in motion, right? All the vehicles are in motion. There is the general weaving action that is taking place. There will if there is any merging or diverging between the traffic, that is also taking place in a very safe and in a very sound manner. And the traffic stream, the traffic stream is always in motion. The traffic stream is always in it is always in motion, right? When this happens, when when the traffic density is such that there is no unreasonable delay, no hazard or restriction towards the commuters that are or the vehicles that are moving in the road section. Let's say again repeat this definition: maximum number of vehicles that can pass a given point on a lane during 1 hour without traffic density being so great so as to cause unreasonable delay or hazard or restriction. Right? There is no unreasonable delay, there is no hazard situation, and there is no restriction. The vehicles are always in motion. Though if there is a merging traffic, there is a diverging traffic, there is overtaking, right? It is happening. Right? There will be vehicles that are moving at a different speed. That is happening. But vehicles are in motion. The vehicles are always in motion. So that traffic volume is what we call as that traffic volume is what we call as the practical capacity. Okay, this traffic volume is what we call as the practical capacity, right? So I hope these definitions are like clear to you. So let me just ask you one thing. What will like the possible capacity is under the prevailing roadway condition, that is the actual traffic condition that we record on the field. So what could be the minimum value of possible capacity? What could be the minimum value of traffic this possible capacity, and what will be the maximum value of possible capacity? What will be the minimum value? What will be the maximum value? Just pause the video here and think about it. Okay. And once you are done, just think in your mind and then resume watching the video. So I hope you have thought about it. So the minimum capacity. What will be the minimum capacity? So as we have discussed, traffic capacity is the maximum number of traffic volume that are crossing the road section, right? So possible capacity can be a scenario where the traffic volume becomes so high. The traffic volume becomes so high. The traffic volume becomes so high that a traffic jam condition arises. Right? The traffic jam condition arises. And at that scenario, when the traffic jam happens, there will be no vehicles, zero number of vehicles that will be crossing the road section in a unit time. Let's say the traffic jam is so huge. We can see that kind of traffic jam in metropolitan cities like Delhi, in Mumbai, where many times the traffic jam happens and it lasts for 1 hour, 2 hours, and like that, right? So in that scenario, when the traffic volume becomes so high that zero vehicles are crossing the road section, right? When zero vehicles are crossing the road section, that scenario where zero vehicles are crossing the road section will be the minimum value of practical this possible capacity. This will be the minimum value of possible capacity. So the minimum capacity can be zero. The minimum capacity will be zero, right? The minimum capacity will be zero. Why? We are looking at the number of vehicles crossing the section, right? The basic definition is the vehicles have to cross the road section. Since during the extreme traffic jam condition, no vehicle is crossing the road section, though, so the minimum capacity or the minimum possible capacity will be zero. Got it? Then we have maximum practical capacity. What will be the maximum practical capacity? Maximum practical capacity when all the vehicles are following the ideal scenario, right? Everyone is moving in a very streamlined manner. Everyone is following the traffic rules and regulations, or all the restrictions that have been imposed are being followed. There is no overtaking. Everyone is the visibility is clear. Everything is at the ideal scenario. And when everything is when the traffic volume at this ideal scenario is what we call it is the basic capacity. So the maximum practical capacity, the maximum possible capacity will be what will it will be? It will be basic capacity. Okay, it will be basic capacity. All right. I hope it is clear to you. Right. If you have any doubt, you can always ask in the comment section. Okay. So this is the minimum value of possible capacity is zero. The maximum value of possible capacity is basic capacity. Right. Now, again, let me ask you one question. Which among three? We have basic capacity, we have possible capacity, and we have practical capacity. Which among these three you think will be used for the design of the road capacity? Which among these three, with the basic capacity, the possible capacity, and the practical capacity, which among these three will be used for the design of the road capacity or the traffic capacity? Pause the video, think about it, put your answers in your mind, and then we'll discuss. So I hope you have thought about it, and you have pinpointed one option among these three. The answer will be, for the design purpose we will have practical capacity. Okay, for design purpose we will have the practical capacity. Now some of you might have chose the option basic capacity. The reason why basic capacity cannot be taken as the design capacity is that it is an ideal scenario. Like we discussed, it will never happen. Like once in 100 years, even that also it's very hard to say that it will ever happen. All right, it's a very ideal scenario. It's a theoretical concept that everything is aligned to itself. Everything will be in a perfect scenario, right? And it's so this will never happen, right? So they will be overtaking. It's an obvious phenomenon. When you drive on the road, you will overtake a slowly moving vehicle, right? Sometimes if the speed limit is, let's say, 30 km/h, you will go at 35 or 40 km/h, right? If the road is empty. So or even if there is a mid amount of traffic volume, you will overtake, right? So this is a theoretical concept. So that is not not a desirable way to, because it's a theoretical concept, so it's not a desirable thing. While your practical capacity takes into consideration all the practical scenarios that happens on the road, right? They will be merging and diverging traffic. They will be weaving action in the road condition, and all the practical things that we see why the vehicles are always in motion, right? And it also takes into account that there should not be any reasonable delay. There should not be any hazard or restrictions that should prevail, right? So that is why it's a while this possible capacity is it what we observe on the road during the traffic survey. What we have observed on the road, that is the possible capacity. So again, it is like the actual scenario. We have to improve from that, right? So practical capacity is what we take as the design. We take as the design capacity, right? This capacity is taken into consideration for the design. Okay, so this is your basics about the traffic capacity. Okay, I hope it is clear to you. If there is any doubt, you can always ask in the comment section. Okay. So we have discussed about the basic capacity, which is also called as theoretical capacity or theoretical maximum capacity. So to find out the theoretical maximum capacity, the formula, we have two formulas. One takes space headway into consideration and one takes time headway into consideration. So we'll discuss about space headway and time headway in detail. But for here, your space headway is your space headway is defined as the center to center distance between two vehicles, right? It is the center to center distance between two vehicles that are in motion, right? That are in motion. Okay. So space headway is the center to center distance between two vehicles that are in motion. We'll discuss about this in a separate lecture about space headway and time headway. Just for this lecture, I'm discussing few basics about this. So you can see if this is the space headway, so space headway, and this is the spacing between the vehicles, that is denoted by SG. That SG we call as the space gap. SG is called as the space gap. All right. So we can see space headway is this, right? Which includes the half length of this vehicle, which includes half length of this vehicle. Okay, this includes half length of this vehicle, assuming both vehicles are same. We have the average length of vehicles, right? Both vehicles are same. So your space headway can be defined as the half of L. Let's say L is the length of the vehicle, half of L here. So we can say space headway is the, I should use capital L. So L, half of this plus SG, right? Plus SG. SG is the space gap, right? Now this space gap is defined as, your space gap is defined as 0.278 V into T. Okay, where V is in kilometers per hour and T is the reaction time. T is the reaction time, which is taken as 0.7 to 0.75 seconds. Okay, so your space headway is equal to L plus 0.278 V into T. 0.278 V into T. Now T is 0.7, conventionally taken as 0.7 seconds. So if we take T equals to 0.7 seconds, so the space headway will be L. The space headway will be L plus 0.278 into 0.7 into V. So this expression, if you multiply this comes out to be 0.1946, which is we can take as 0.2. Okay, so this expression becomes L plus 0.2 into V, where V is in kilometers per hour. Okay, this expression becomes L plus 0.2 into V. So we can say our space headway S is equal to 0.2 V plus L. Alright, suppose in the question it is the reaction time is given different, and then you have to use this formula 0.278 V into T, right? So I'll just write here also. Okay, so I'll write here, this is when we take T is equal to 0.7 seconds, which is the reaction time. T equal to 0.7 seconds. Otherwise, the formula for S is 0.278 V into T plus L. Right? The length, the average length of vehicle we can take as 5 meters. Right? If not given in the question. Right? Average length of vehicle we can take 5 meters. If not given in the question. If given in the question, that we can take L equal to 5 meters. Okay. So this is the maximum theoretical capacity C equals to 1000 V by S with respect to the space headway. C equal to 1000 V by S. V will be in kilometer per hour. S is in like meter. Okay. So this is the formula for theoretical maximum capacity in terms of space headway. In terms of time headway is defined as let's say this is your reference point, and we have number of vehicles that are crossing this reference point, right? So time headway is defined as the time taken to cross the successive points of vehicles from the reference point. Successive point means, let's say you have taken the front of the vehicle. You have taken the front of the vehicle as the reference point. So let's say at time t1, the vehicle crosses the reference point. So after that, the time taken to cross this reference point, the front of the vehicle to cross your reference point is t2. This is t2. So t2 minus t1 will be the time headway. Okay, the reference point has to be same. I will repeat, the reference point has to be same. So you can take the front of the vehicle, or you can also take the back of the vehicle as the reference point, right? In that case, if you are taking the back of the vehicle, as soon as the back of the vehicle of the crosses, it will be t1, and then the back of the second vehicle it crosses, it will be t2, right? So time headway is the time required to cross the successive points of the vehicle from the reference point. Okay, so if ht is the time headway, so c is equals to 3600 by ht, right? It will be 3600 by ht, right? It will be in second. It will be the unit will be second. Okay, so let's quickly do one numerical on that. Okay, the question says that we have to find out the maximum theoretical capacity of highway, one lane road where traffic is moving at a speed of 55 km per hour. The average length of vehicle is 5.2 and time headway is 2.5 seconds. Okay, this is the question. Write down the question, pause the video, write down the details, and you have already noted down the formula. This is the formula. Solve it by yourself, and then move ahead. Pause the video, solve by yourself, and then we'll move and solve the question. Okay, so I hope you have solved the question by yourself. So let us let's solve it together now and see if you have got the right answer or not. Okay, so here the maximum theoretical capacity is asked. So it is not saying that with respect to space headway or with respect to time headway. so we are going to find both. So the first part, as per speed, I'm going to do quickly. It's a very simple numerical. As per speed, the capacity is 1000 V by S. S is the space headway, and we know what we are given. We are given the speed of the vehicle. We are given the vehicle length, and we know S is equals to 0.278 V into T plus L. Right? V is velocity in kilometer per hour. We are given this value. L is the length of the vehicle. We are given this value. T is not given. Right? T is not given. So we'll write, since reaction time is not given. Since reaction time is not given. So we'll take 0.730. It is very important to mention this, right? If whatever the standard data that you are taking, it's very important to mention this, right? So reaction time will be 0.7 seconds. So S is equals to so it will be 0.2 into V plus L. So it will be 0.2 into 65 plus L is 5.2, right? So it will be 18.2 meters. Putting the value C max, that is the maximum theoretical capacity, will be 1000 into V. V will be 6.5 sorry. V will be 65 kilometers per hour. V will be 65 divided by 18.2. It will be 18.20. So upon solving, the answer will be 65 into 1000 divided by 18.20. So the answer will be 3571.428. So we can just write 3571.4 vehicles per hour for let's say. Okay. With respect to time headway, the th that was given to us in the question was 2.5 seconds, right? It was given to us as 2.5 seconds. Okay, so C max will be 3600 divided by 2.5, right? 3600 divided by 2.5, so that will be 1440 vehicles per hour, right? It will be 1440 vehicles per hour. So like this, you solve the numericals. Okay, simple. Just put the values, get the answer. All right. So let's quickly discuss the factors that affect the practical capacity. Factors that affect the practical capacity. Factors that affect the practical capacity. Okay. So the first one will be lane width. So tell me what will happen if we increase the lane width. If we increase the lane width, what will happen? When we increase the lane width, the practical capacity will increase, because if this was the lane, then we had small sections for the vehicles to cross across this. If we increase the lane width, so the number of vehicles will increase that will crossing the road section. So if we increase the lane width, the practical capacity will increase. Okay. Second is the width of shoulders. The second is the width of shoulders. Tell me, if we increase the width of shoulders, then what will happen? If we increase the width of shoulders, then what will happen? So let's say if this is the shoulders along the carriageway, right? If these are the shoulders, and then we increase the width of shoulders, right? And then we increase the width of shoulders to this one, so the carriageway decreases, right? The carriageway decreases. So if we increase the width of the shoulders, the practical capacity will decrease, right? Third is the commercial vehicle. If the number of commercial vehicles increases, means tandem tractor and tandem trucks, right? Tandem trucks, right? So if we increase the commercial vehicles in a road section, if we increase the volume of commercial vehicles, then what will happen? The practical capacity will decrease. Why? Because trucks move at a lower speed than your private vehicles like car, your bike. It moves slowly. So if we have high number of trucks that are going in the road section, so of course the vehicles that are following them will not have space to cross. So of course the number of vehicles that will be crossing will decrease, right? Apart from that, your traffic capacity is also dependent upon the alignment of the road. It is also dependent upon the road geometry. And it is dependent upon the presence of intersection. Right? If we have like higher amount of intersection, so number of vehicles that are crossing will be higher, right? So it will, if there are too much intersection, then the practical capacity will decrease. the alignment and row geometry are, if not as per the relevant code, then the practical capacity will decrease. Okay, so these are few of the parameters: the lane width, the width of shoulders, the number of commercial vehicles, alignment, road geometry, and presence of intersection. Right. So these are the parameters that affect the practical capacity. Okay. So I hope this concept of traffic capacity is absolutely clear to you. Okay. And even if you have any doubt, you can always ask in the comment section, right? And you can in the comment section tell me what improvement can be done in making the video, and what topic you want me to create a video of, right? And like, if the video was useful to you, make sure you like the video, right? And share the video among your friends, and do subscribe to the channel. Do subscribe to civil engineering and stuff for more videos like this, right? Thank you for watching. I hope the video was useful to you, right? Thank you for watching. Have a nice day.